Hello, my name is Drake, and welcome to a lesson on Android networking. So first off, we're going to talk about how networking works, especially in regards to Android. And then we're going to run through a demo about how you can use networking in an Android application. So first off, what is networking exactly? So when I'm talking about networking, I'm not talking about like the networking in like the professional setting, like on LinkedIn. I'm talking about making computers talk to each other to share information. So far you may have like built a basic calculator app, dealt with input and output something else. But so far all the logic and information for your application has been on your device. But what happens if you want to talk to the outside world? What happens if you want to get current tweets, or you want to get weather information? All sorts of useful information. You want to send information to store in a database. You want to get information from a database. A lot of apps that you'll use will implement networking. So networking works on this request-response model. So you have a client and a server. A client makes a request, and a server is just another computer that sends you information, or takes your request and stores the information you sent it. So all the internet is really just a bunch of different computers networked together. And typically servers are special types of computers. They might be in a data center somewhere, but they don't have to be. And an Android device is also a computer. So that's all a client and server is, just two computers talking to each other. So let me give you an example. It's almost like when you call like a pizza shop, right? You would call them, you make a request for whatever you want, and then they would eventually they'd send a delivery driver out with your pizza. It's sort of similar to that. You have the client making the request, and then the server handling that request. So networking is a really complicated matter because you could literally be sending information or requesting information from across the globe, and it could go through multiple different destinations in order to get there. And the connection can actually be like a physical line could be severed, like there's a backhoe somewhere, and they sever the fiber connection, and the request still completes because of how the internet works. The really fortunate part as developers, we don't have to worry about all the underlying stuff. All that's abstracted away from us. We only need to tell Android where we want the destination to go and what parameters to send. What kind of requests are we making? What kind of resource do we want? We don't need to worry about any of this routing stuff or anything underneath. If you're interested more about this, it's called the OSI model and also TCP/IP model. If you're interested in sort of the underlying, what goes on under the hood. So there's a bunch of different protocols to make and send requests, but the most common one is HTTP/HTTPS. HTTPS is just the secure version. And you probably have seen this before. It's the standard protocol you use when browsing the internet to view web pages and web applications. And commonly to interact with APIs or services, this is also the most common method to get and send information. However, instead of getting a web page, you're getting usually a text file in a certain format that contains the information you want to display within your app. So within HTTP, there are what we call methods. There are these verbs that we use to describe what kind of request we're making. The four most common is get, post, put, and delete. So I'm going to use like a to-do list app example. Let's say you have a to-do list app, and you want to store users' to-dos in the cloud. In case they lose their device, in case they get a new device, they have an account, and all their to-dos are stored in the cloud. So with our to-do app, using these methods, you would want to get a list of to-dos, right? With post, let's say they have a new to-do item. Well, you would post that new to-do item to the backend database. Put is usually updating a resource. So let's say they go in and change the title, or maybe they change the due date of a to-do task. You might use a put. Let's say they complete a to-do or want to delete it. Well, then you would put a delete request. And all these are kind of arbitrary. They're kind of standards. Usually it will be a backend server that will have a certain function or handler that will run for each of these requests. So let's look at the anatomy. Now that we know what the methods are, let's look at the anatomy of a request itself. So typically in a HTTP request, you're going to have a few different pieces of information that you're going to send in the request. So first off, you're going to send the method, that we talked about in the previous slide, the get, the post, and so forth. And you're only going to have one method for a request. And then you're going to have a route. So where's this request going? So you have a typical URL, like, URLs like google.com. But then, you have the forward slash after, whatever comes after that. That's typically your route, your resource that you're trying to get. So back to the to-do example. Let's say you make a backend service to handle your to-do list. Well, maybe you have slash to-do slash list, and when you send a GET request to slash to-do slash list, it will return you a list of all to-dos. Just for example. Maybe you'll have like slash to do slash a certain ID, and then that will get just one to do. And this is kind of a common format you see in services, or what we call API, or application programming interfaces. That a lot of different services will allow you to get information from their systems, or you can build your own API to build your own system, like with a to-do app. You'll have a header that will have stuff like authorization information, maybe the type of data you're sending or the type of data you want back, so like what format of data you want back. All that kind of stuff goes in the header. And then you'll have a body. So the body's optional. You'll typically only send it on like post and put requests. It's like in the to-do app example, if you're creating a new to-do, you'd put the to-do title and the to-do due date and stuff in the body. Now if you're doing a GET request, you're not sending any information to the server, so you wouldn't have a body. It'd be empty. Alright, so we've sent our request, the server's processed it. Now the server needs to send us a response. And the first part, what it does in the response is it sends you a status code. And the status codes are basically a standardized way of telling the client, how the server handled its request. And they're kind of grouped by the first digit there. They're all 3 digits. The first one's one, whatever. It's informational. I don't see this a lot. The 200s are success. The 300s are redirection. 400s are client errors, and 500 are server errors. So like with the 400s, you may have seen before, like 404 not found. So like the error code 404 corresponds to resource not found. So, if you made a request to, slash to do slash ASDF, to your server that you made, and let's say that doesn't exist. Well, the server would send you back 404 not found. And so that way in your app, you can take these status codes and handle it. Maybe you need to show an error, or maybe the server sent back I think 400 is invalid, maybe? Don't quote me on that. So maybe it displays an error message saying, hey, you didn't make this correctly. You can kind of handle the different error codes to show different errors to your user. And this is a lot of information, so you don't need to know all this, especially off the top of your head. But this is just a brief overview of kind of the different concepts and ideas that go into network requests. So also in the response, alongside with the status code, you'll also have a header. Again, metadata about the response. And then the body. The body will contain, whatever you requested. So let's say you did a GET request, again, back to the to-do list application. Let's say you did a GET request for all the to-dos. Well, the body will contain maybe an array of all the to-dos. This is a fun little anecdote. There's a HTTP status code for I'm a teapot. It was added April Fool's, but it's like technically kind of part of the specification. Yeah. Okay, so let's go back to our kind of diagram of the request response model. So you have a client, your app, the phone, making the response. Let's say this is a news app this time. So you'll have like the base URL, like let's say it's CNN.com, and this probably won't actually work, but just for example, right? Our newssite.org, or totallynotfakenews.org. That'll be the base URL. Then after that, like the .com or .org or whatever, we have our resource URL, our route, sorry. So our route's /headlines. So we're telling the server, hey, I want the resource at /headlines, and it's a GET request. The server's saying, okay, here you go. It's a 200 response, so I was able to do everything. And then the body, the body is the list of the data that you wanted. So the client sends a request, the server responds back. So request sends a request, server gets that request, processes it, and then sends a response. Now, that response, it has to be, we're sending the response data somehow, and when you use the internet, that response is like an HTML document to form a web page. Now, your application doesn't want an HTML document. You want just the raw information so you can visualize it and render it how you want. So there's there's more than this, but there's two main common ways that services will send you, that you can send services information and services will send you back information. This is just a way of encoding information. The most popular one is called JSON, JavaScript object notation. You'll see this probably mostly. XML is another one. You see it more in older or legacy or quote unquote enterprise stuff. You probably won't run across this a lot, and if you do, I'm sorry. So first off, how do we actually do this in Android? We've been talking about the high-level concepts, but now how do we kind of bring that back down and actually implement networking in our application? So the first thing we need to do is actually tell the application that we need permission to use the internet. We need to tell the Android operating system that our application needs to access the internet. To do this, we add a line in our Android manifest. It's like Android manifest.xml. We basically configure the application to tell the Android OS, hey, I need to use the internet. So we add this permission. You'll also see this format for like if you need to use GPS or need to use the camera. All these things are called permissions that your application needs to use. The second thing is that requests have to be done in the background. So if we go back, notice how I said this is not an instantaneous process. When we send a request, it has to travel to wherever the server is. That could be down the street or that could be across the globe and you don't know. Then also the server has to process that request and send it back. And it's not even guaranteed that your request will make it there or the response will make it back. So the request could happen, anywhere from a few milliseconds to a couple seconds or never even complete. So because of this, requests have to be done in the background. And what I mean when I say they have to be done in the background is that it can't be done on like the main thread. If that doesn't really make sense, I'll kind of give you an example. If the request is done in the main thread, that means your application is waiting for the request to complete before it does anything else. So if the user tries to scroll or interact with anything in the app while it's doing a request, the app will be completely frozen. And this leads to a horrible user interaction. And I don't even think Android will let you do this because it's just a bad idea. So what we had to do is just basically tell our application to make a request in the background so it's not locking up anything else. And then, while it's done in the background, it will basically yell back at you when it's done. So this is a Java example. So there's built-in classes and methods within Android to make these HTTP requests. It's quite cumbersome and not fun to handle. So this is the Java example, and this is it's not fun. This is the Kotlin example. It's a little bit cleaner, but it's still cumbersome, and this is not even doing it like within an async task. So this is just kind of a pain in the butt. Luckily, there are a lot of different third-party libraries, so code that other people have written that you can use in your application, that makes dealing with HTTP and making requests a lot easier. So there's a lot of different lots of different ones of these. Today we're going to be focusing on RETROFIT. Volley is another big one. There's multiple ones out there, and there's no best one. It just depends on your needs, but we're going to be teaching RETROFIT because it's one of the more commonly used ones. So with RETROFIT, you define basically an interface of the different routes that your application will need to access. So this is using an example for like a GitHub API, right? So we have defined our GitHub service. This is the route after the API.github. So this is our like base URL, but after api.github.com, these are like, we could have a bunch of different resources, right? It could be like users/info, and then we can maybe put and post. This is just a basic example with just one resource though. The cool thing about this is it scales really well. There's a lot of setup required initially, but as soon as you want to add more stuff, it's very easy because you've already done all the setup. But you define a repo, you define an interface that has a route. So we use this decorator here, the @get, to define the type of request we make to this route. And then here inside these curly brackets just mean it's a parameter. So the users, that might be like a user ID, and For the example we're going to be doing in a second, we're not going to have a path parameter, so this and that isn't going to be there, so don't worry about that. But after the decorator here, that just describes a decorator describes a function. We're just going to have a function. We're going to name it list whatever, or get, or put, or whatever we want to name it, and then the parameter it takes. So right now it's taking a path parameter for that right there. But in the example later, we won't need one of these. And it will return a type call and a list of repo objects. So the cool thing about retrofit is it uses standard Kotlin or Java objects, and it will automatically parse the information you have incoming from your request into these objects, which I'll show you more in a second what that looks like. So next we have we start the retrofit object. We use the builder pattern. If you're familiar with like object-oriented patterns, we set the base URL, we build it. Here we can also insert our converter, and then we tell the service to create retrofit to create it from this service up here. Now what it's doing, notice this is an interface. We are saying that there's a function named this, and we're saying it takes in this and returns this, but notice we aren't actually implementing it. The cool thing about retrofit is all it needs is this information, and it will do everything under the hood automatically for you. So then all we need to do is call services.listRepos and pass in the parameter if we have a path parameter, and it will make the request, and then on response it will set repos to the list of repos. Okay, so that's a brief overview. So now we're going to actually look at what that looks like implemented. So for this lesson, we have a basic application that lists upcoming SpaceX launches. There's a cool free API that you can use that will display upcoming launches of SpaceX. So all the UI is already done for you. All you need to do is hook up the UI to making the request yourself. So what it should do is it will display a list of upcoming launches. It'll have a badge if available. It'll have the title. It'll have a description, and then the launch date. And the cool thing is we've already done a lot of the work for you. All you need to do, again, is hook up the networking component, and there's several to-dos in the code. So to get started, first off, you need to go to the SpaceX Launches repository on GitHub. So it's just github.com/git-mad/SpaceX Launches. Or you can just search up this. Then once you're here, you can go to the green code download, and you can either git clone on the command line or download zip. So if you're downloading the zip, just extract it to whatever folder you use for your stuff. Remember to extract it. You might use documents. I keep like a separate workspace folder for all my code, but you need to extract it just somewhere that you can remember. So there's a list of steps to finish the application. So first off, we need to add the internet permission in Android manifest.xml, like we mentioned earlier. Next, we create a retrofit service to get upcoming launches. We set the base URL for the API, and so on. So there's a list of stuff we need to do, and there's also comments within the code giving you hints about what you need to do. However, if you get stuck, there's also the completed code. So if you go up here where it says main, if you click on it, you can switch branches to the solution branch. And then the solution branch will have the final application. So it'll have all these to-dos filled in the solution branch. So if you get stuck or don't know what to do, you can always hop on over to the solution branch. And that's about it. Yeah, if you have any questions, feel free to post in the help channel in the GitMad Discord. I hope you've enjoyed this tutorial, and keep an eye out for future ones.